This is Algebra 1, Lesson 1.5. We're going to talk about equations today. So we get to solve equations. So the first thing they want to talk about is an open sentence. Basically, an open sentence is just an algebraic expression. Algebraic expression. Which means you can't, that's an R, not an I. You can't solve it. You can only simplify. Algebraic sentences or open sentences, algebraic expressions are things you simplify, you can't solve. If you want to solve, you have to have an equation. So maybe this would be, maybe put in parentheses, simplify versus an equation you solve. The equation has equal sign. So that's the difference between an open sentence and an algebraic expression, or an equation, sorry. One has an equal sign, one does not have an equal sign. I'm going to put on here something that you need to know. So I'm going to big star there, okay? I'm going to call this the golden rule. The golden rule of equations. And we're all going to say it. And it's what you do to one side, you do to the other. What you do to one side, you do to the other. Say it.
What you
Do to one side, you do to the other. Guys, it's very easy to forget this, that if I add 2 to the left side, I have to add 2 to the right side. If I subtract 5 from the right side, I subtract from the left side. If I add or multiply to one side, I have to multiply or divide. Doesn't matter. If I take something to a power, you do it to both sides. You square root one side, you square root the other side. You need to get that in your head. You can't just do something to one side. You can simplify a side, gathering like terms. That doesn't change things. That's substitution. But if I am going to physically take something away, or add it, or multiply, or divide it, I need to do it to both sides. The first type of problems that you guys are going to encounter is they give you an equation like 8m minus 7 equals 7. And they want to know, of your various choices here, which one of these is true. And actually, guys, I made a mistake. It's 17. So, here's the equation. Oh, sorry, over here. Here's the equation. These are your possible solutions. So they're actually giving you a solution somewhere. It's one of those 4 choices. A 0, 1, 2, or a 3. Your job is to show which one of these works in there. And so, this is what I'm going to do. 8 times 0 minus 7 equals 17. This, guys, is what I call checking. When I do this, all I'm doing is simplifying. What's 8 times 0? And 0 minus 7 equals 17, or negative 7 equals 17. Is that true? No. So guess what? 0 is not the solution. And then I go to 8 times 1 minus 7 equals 17. What's 8 times 1? 8 minus 7 is 1 equals 17? No, that doesn't work. I then go to, is it 2? 8 times 2 minus 7, does that equal 17? 16 minus 7 equals 17. What is 16 minus 7? 16 minus 7. 9 equals 17. No. Hopefully 3 works. What if 3 doesn't work? That means the answer is just not in that solution set, right? So 8 times 3 minus 7 equals 17. What is 8 times 3? 24. Minus 7, does that equal 17? Yes, 17 equals 17. Check. That means 3 was our solution. So maybe go back up and say 3. So your first group of problems, it's going to give you that. Test them. Find it, one that works. Guys, this is what I call checking. And you need to write down the steps. Notice what I did not do. I did not go up here and add 7 to both sides. If I added both 7s to both sides, I would not change the equation, I just change the appearance. When I'm checking, guys, do you notice that all my equal signs are, fairly down a straight line here? I'm able to see that, see that there's a wall. And when I'm checking, I act like the wall is something I can't cross. And then what happens is that you get down all the way to the end, and you get down to single numbers, and what happens is they kind of peer over the fence. It's like a wall. So all of a sudden they look over the wall, and they look at each other going, are we the same? No. No. Not good. And then down here, they look over the wall and say, hey, we're identical twins. That's awesome. We're meant for each other here. This is the solution. Okay? The second homework type of problems, it says solve it. But you're like, hey, wait a minute. T is the variable. T is already solved for. T is by itself, right? That's my goal. But unfortunately, it's not simplified. So this one is you need to simplify using order of operations to solve it. So what comes first? 9 squared. The 9 squared divided by the quantity, or should I do the quantity of 5 minus 2? Parentheses should come first. Now, is that going to be affected if I take 9 and square it? Because exponents probably are next, right? Can I do both of those things at the same time? And the answer is yes. Because the 9 squared and the parentheses are separated from each other. So what's 9 squared? It's 81. Divided by, what's 5 minus 2? 3. And that equals t. Notice that front equals t. It's all going down, straight line here. And what's 81 divided by 3?
27.
27. So guess what? T is equal to 27. So just simplify using your order of operations. So now what we're going to do is solve this equation. Notice that it's got n. We've got to solve for n. And to solve for n, we also recognize that there's n's on the left and on the right side. So to solve our equations, you need to simplify each side. Order of operations. I got parentheses. What's 3 plus 2? 5. So it'll be n times 5. Plus 6, because 6 is just going along for the ride, equals 5n plus, what is that? 7. 10 minus 3 is 7. This one's interesting. Wait, n times 5, isn't that just the same thing as switching the order there? Does that say 5n plus 6 is equal to 5n plus 7? So what can I do? Now, to officially solve this, I need to get the variables on the same side, numbers on the other. But 5n plus 6 is equal to 5n plus 7? Does it matter what I put over n? 5 times n is the same thing as 5 times n, right? So, if you think about it, if I'm going to take the same thing on both sides and add a 6 or a 7 to it, will I ever get the same number? No. There's actually no solution to this. There is no solution to this problem because you can't take a set quantity and add two different values to it and get the same number. No matter what you start with, 0, 1, 10, 15, negative 5. If I added 5 to both, added a 5 to one and a 7 to another, they'll never be the same number again. Now, how would I go about showing this? What would it look like if I go to solve it? Well, to get 5n from one side to the other, we would subtract, right? But what you do to one side, you have to do to the other side. These cancel, these cancel. You're left with 6 equals 7. Is that true? Never true. So therefore, no solution. So our next problem I want to highlight is, again, this one kind of looks like I got to solve for n, but it almost seems like I have to do this simplifying stuff again. So a lot of our problems in the beginning are going to be simplify, simplify, simplify before we can solve. And I think we got a set of parentheses there, but we also have an exponent inside the parentheses. So that exponent will take precedent over everything. So it'll be 7 minus the quantity of, what's 4 squared? 16 minus 10. Okay, and what's 16 minus 10?
6.
Is 6. And everything else, guys, is just going along for the ride. And what's 7 minus 6?
4.
Now, I'm just one step at a time. Now, the book actually stops here. The book wants to say, you tell me the value. 1 plus what is 10? It's 9. So we're going to use that intuition, but I don't want to just stop there. I want to use that idea, that golden rule, that what I do to one side, I do to the other. I want to get n by itself. To get n by itself, I will subtract 1 from both sides of the equation. So n equals 9. Okay, so let's solve this one. And notice that the left-hand side is simplified for us. The right-hand side is not. So I'm going to take the left-hand side and bring it along for the ride. And I'm going to distribute, right? We use the distributive, so it's 3x minus what? 6 plus 10. Can I simplify this anymore? I can simplify the right-hand side by taking the negative 6 and 10, put those together, and I'll get what? What happens when I put those two together? What's negative 6 plus 10? Plus 4? Hey, wait a minute. Wait. 3x plus 4 equals 3x plus 4? Isn't that always true? Isn't that the same thing?
Yeah.
That means that there's always a solution, right? No matter what I put in for x, I'll always get the same thing on the other side. So this is all real solutions. Sometimes they say infinite many. Or infinite many. One of those two. All real solutions, infinite many solutions. But why? What does it look like? Well, I gotta get the x's by themselves. Maybe I'll just subtract 4 from this side. But if I do it on the left side, I need to subtract 4 from the right side. So those are gone. So I get 3x equals 3x. Well, that's still true. Oh, wait. Why don't I just subtract 3x from both sides? You bring the x's to one side. Wait a minute. That'd be 0 equals 0. 0 equals 0? When is that true? When is 0 equal 0?
Always.
Always. Therefore, there's always a solution, or all real solutions, or infinite many solutions. So part of the problem you're going to solve, you're going to find one solution. Sometimes you're going to solve you're going to get 2 equals 2, 5 equals 5, negative 3 equals negative 3, x equals x. They all come down to 0 equals 0, which means infinite many solutions, or you get to a point where it's 6 equals 7, a negative 3 equals 10, which is never true, which means there's no solution.